Hello, welcome to lecture 2.5C. This is the third lecture and final lecture before the quiz over implicit differentiation. Just going to work you two more problems from page 139. And the first one we're going to work is number 26. Okay, so we've got, we want to find the equation of the tangent line, and we have y squared is equal to x minus 1 over x squared plus 1. And our point is 2 square root of 5 over 5. Now, we could go through this and use the quotient rule, but we're going to get just a big, nasty fraction that we're going to have to deal with. I would rewrite this equation as y squared, multiply both sides by x squared plus 1, times x squared plus 1 is equal to x minus 1. So we're basically just taking the denominator, multiplying it by the variable out front, and setting it equal to the numerator. It's the exact same thing as this. And let's go ahead and distribute the y squared. So I've got x squared y squared plus y squared is equal to x minus 1. And now we will differentiate that with respect to x. Product rule, the first, x squared times the derivative of the second, 2y dy dx, plus the second, y squared, times the derivative of the first, 2x, plus we're on the y squared term now, so that would be 2y dy dx, and the derivative of the right side is just 1. So now let's collect the dy dx terms over on the left. I'm going to clean it up a little bit, so we'd have 2x squared y dy dx plus 2y dy dx, and subtract this 2xy squared, so I'd have 1 minus 2xy squared over on the right if I rewrite that with the x's and the 2 first, and then move it over to the right, it makes it negative. Let's factor out a dy dx. Have 2x squared y plus 2y. And then finally, dy dx is 1 minus 2x y squared over 2x squared y plus 2y. Now I'm going to plug in this point, 2 root 5 over 5. So that's to get the slope. So I'd have 1 minus 2 times root 5 over 5, all squared, over 2 times 2 squared, times root 5 over 5, plus 2 times root 5 over 5. All right, that's a bit of a mess, but let's try to clean it up. Root 5 squared is 5. 5 squared is 25. That's 5 over 25, or a fifth. 2 times 2 is 4. So on the top, that'd be 1 minus 4/5. All right, 2 squared 4, that'd be 8 root 5 over 5. Plus 2 root 5 over 5. Since we have a common denominator, we can add the top. 8 plus 2 is 10. 1 minus 4/5 is 1/5 over 10 root 5 over 5. Now, we can flip the bottom fraction and multiply. You can see the 5 will cancel. And we have 1 over 10 root 5 is the slope. So our tangent line equation is y minus root 5 over 5 is equal to 1 over 10 root 5, the slope, times x minus 2. And goodness, let's just leave it like that. All right, a good solid problem to work. I'd say of medium difficulty here, and this is a little harder to plug in with the radicals and everything and not make a mistake, but a really good problem. If you got that, if you get one like that right, you know, we probably have something of equal difficulty on the homework. Okay, and number 42. On this, we have to find the equation of both the normal line, remember that's the perpendicular line, and the tangent line. We have x squared plus y squared is equal to 9. I'm just going to do the second point. So let's do 2 root 5. Okay, if we were to, this is just a circle of radius 3. So that's 2x plus 2y dy dx equals 0. So I have 2y dy dx is equal to negative 2x. So dy dx is equal to negative 2x over 2y, which is negative x over y, which is always the formula for a circle. All right, the slope then is we're going to plug in 2 root 5 into that. So that'd be negative 2 over the square root of 5. So our tangent line equation is, and since we're doing the normal line, but the tangent would be y minus root 5 is equal to negative 2 over root 5 times x minus 2. Now our normal slope is we take the negative reciprocal, so that's root 5 over 2. Get rid of the negative sign and then flip. So the only difference in the equation from the tangent line and the normal line is the slope. So it'd be y minus root 5 is equal to root 5 over 2 times x minus 2. Okay, the book probably puts this in slope-intercept form by moving that root 5 to the right and multiplying through by root 5 over 2. Again, you don't have to do that. This is perfectly fine. Okay, the homework, and I do have a hint on one of them, is page 139. And the homework is 21, 23, 25, 29, 41, and 45. So let me give you a hint on 45. So you want to find where there is a horizontal and a vertical tangent line. So for the horizontal tangent line, so you're going to, when you take the derivative, you're going to get a fraction. Okay? Set the numerator equal to 0 and solve. Okay, and so you'll end up solving for x, I believe, on that one. It may be y, whichever one you have, but you solve for the variable. Whichever one the numerator has. It could be x's, could be y's, I don't remember. And set numerator equal to 0, solve, and plug in to the original equation to get the other point or other variable. Okay, what do I mean by that? What I mean is if you're solving for y, all that's left is y in the numerator, and you solve and you get a y value, plug that back into the original equation and solve for x. And then you'll have a point xy where you have a horizontal tangent line. So for the vertical tangent line, that's where you set the denominator equal to 0. So the denominator will just have an x or a y in it, and you set that equal to 0. You solve, and then you plug back in just like you did for the horizontal tangent line to get the xy value. Okay, because where the numerator is equal to 0, that's where the whole function's equal to 0. And where the denominator is equal to 0, that's where the function's undefined, and that would give you a vertical tangent line. Okay, so that's the hint for number 45. You haven't seen one like that before. Everything else we had an example problem on. Let's see, on 29, it gives you a graph. But, you know, you've got a graph on that, but you want to just, you know, ddx it and get the slope of the tangent line, okay? You're not going to... You could probably figure it out by reading the graph, but I want you to show your work on number 29. Even though they've got a graph and you could probably look at the graph and tell what the tangent line would be. Go ahead and take the derivative with implicit differentiation and show your work on that one. Okay, that's all I've got for this lecture. On the homework solutions, I will give you a final review for the quiz, which isn't going to be much of a review because it only covers these 3 sections. All right, talk to you next time.